what if you could boil it all down to just one number? A single number that could act like a fingerprint, telling you if a molecule was made by life or just by random chance. Well, today we're diving into a really fascinating and, pretty controversial idea that tries to do exactly that.
I mean, this is one of the biggest questions out there, right? When we're looking out into the universe, or even just looking back at the origins of our own planet, how do we possibly pick out the signature of biology from all the background noise of regular old chemistry? It's a huge, huge challenge.
So, to tackle this, scientists are proposing something, well, pretty radical. A new way to actually put a number on complexity itself.
And that brings us to assembly theory. This was cooked up by chemist Lee Cronin and his team. Now get this, it's not about how big something is or how heavy it is. Nope. Instead, it measures complexity by counting the absolute minimum number of steps you'd need to build something from its most basic parts. And there's one key rule. You get to reuse the pieces you've already made along the way.
Okay, the best way to get this is to think about Legos. Seriously. Imagine you start with a pile of individual bricks. You snap two of them together. Bam, that's one step. Now you make a different little component. That's step 2. Then you take those two pieces you just made and join them together. That's step 3. Every single unique combination you make adds to the count. That final number, the total of all those unique steps, that's what the theory calls the assembly index.
So, what's the big deal with this assembly index? Why does this one number matter so much? Well, this is where it gets really interesting.
Here's the crucial point, the real punchline of the whole theory. A high assembly index is basically a fingerprint for life. Think about it. Simple little molecules can form randomly all over the universe, no problem. They have a really low assembly index. But what about the complex molecules of life, like a specific protein or a strand of DNA? No way. Those things require a long, very specific sequence of steps to be built. They have a history to them. They couldn't just pop into existence by chance. So a high assembly index is a dead giveaway that some kind of selective process, like evolution in life, had to be involved.
And this is where the theory goes from being this really cool, kind of abstract idea to a tool that could literally change everything. Because what's the ultimate job for something that can spot the handiwork of biology?
Exactly. The search for life beyond Earth. Proponents argue this could be it, the ultimate test. Instead of looking for chemistry that's familiar to us, we'd just be looking for a high degree of complexity. It would be a universal biosignature that could, in theory, detect life that's completely different from anything we know.
And the potential uses are just huge. I mean, imagine a probe on Mars digging into a soil sample. It wouldn't have to look for water or Earth-like organic stuff. It could just measure the assembly index of the molecules it finds. If it finds a high number, well, that would be a monumental discovery. And beyond just looking for aliens, the theory gives us a new mathematical way to look at how evolution actually builds complexity right here at home.
But, okay, like with any big, bold, game-changing idea in science, you have to remember, it's still just that, an idea that's being tested. And believe me, it is not without its critics.
So while the theory sounds incredible, the source material is really clear that its actual usefulness is being heavily debated in the scientific community right now. Is this a true revolution in how we find life, or is it just an interesting but ultimately limited idea? That conversation is happening as we speak, and honestly, that's a healthy, crucial part of how science moves forward.
And that brings us right back to this profound question we started with. Assembly theory is basically proposing that the answer to one of our oldest mysteries might just be a single number. If this idea holds up to all the scrutiny, this assembly index could fundamentally change not just our search for life in the universe, but our very definition of what life even is.
So, if this has got your brain buzzing and you want to play around with these ideas yourself, the researchers behind the theory actually built this fantastic interactive resource. You can explore these concepts and really get a feel for how it all works. We've gone ahead and put the link for you in the description. It's a really great way to get a hands-on sense